For this problem, let's take a look at these limits. The limit as x approaches 3 from below of x minus 5 over x squared minus 4x plus 3. And the same thing, except this time approaching from above. The limit as x approaches 3 from above of the same thing, x minus 5 over x squared minus 4x plus 3. All right, now the first thing we should do is check to see, can I just simply plug in 3? Unfortunately, the answer is no. If I try to plug in 3, I would get 9 minus 12 plus 3 is 0 in the bottom. And so I have a 0 on the bottom, and so I can't just simply plug in. All right, so for this one, we're going to approach this two different ways. First off, method number one, and for test purposes, both methods do not have to be done. Pick the one that you like the most. They're both logically equivalent. For the first one, we have the limit as x approaches 3 from below of x minus 5 over x squared minus 4x plus 3. And that's the limit as x approaches 3 from below of x minus 5, and this factors as x minus 3 and then x minus 1. Okay, now let's plug in 3 as x approaches 3 from below. As x approaches 3, x minus 5, that goes to negative 2. As x approaches 3 from below, x is going to be a little bit less than 3, and so x minus 3 is going to be a little bit less than 0. So that's going to be 0 in the negative sense. And then as x approaches 3, x minus 1, that goes to 2. So I have a 0 in the denominator. I also have negative over negative, and so this blows up and blows up positive. For the second one, it's going to be very much the same kind of a calculation. The limit as x approaches 3 from above of x minus 5 over x squared minus 4x plus 3. And again, I factor the denominator, x minus 5 over x minus 3 times x minus 1. All right, as x approaches 3, x minus 5, that goes to negative 2. As x approaches 3 from above, if x is a little bit bigger than 3, then x minus 3 is going to be a little bit bigger than 0. And so that approaches 0, but in a positive sense. And then x minus 1, if x approaches 3, 3 minus 1, that goes to 2. So I have a 0 in the denominator. I also have negative over positive here. And so this would go to negative infinity. And so those are the answers for the first two questions using this, idea of looking at zeros in the denominator, but caring about whether it's going to 0 in a positive or a negative sense. All right, method number two. Yep. And method number two, we're going to rely on the factorization that we have here. The terms of interest are going to be x minus 5, x minus 3, and x minus 1. The points of interest are going to be 1, 3, and 5. And this does not have to be drawn to scale. It does turn out 3 is the midpoint of 1 and 5. This does not have to be drawn to scale for the purposes of what we're going to use this for. All right, x minus 5, that is 0 at 5. If I plug in something that's a little bit less than 5, I get in something that's negative. If I plug in something that is bigger than 5, I get something that is positive. Likewise for 3. If I plug in 3, I get 0. If I plug in something that is less than 3, I get something that's negative. If I plug in something that's bigger than 3, I get something that is positive. Finally, x minus 1, if I plug in 1, I get 0. If I plug in something that's less than 1, I get something that is negative. If I plug in something that is bigger than 1, I get something that is positive. Okay, now we combine these. We take negative divided by negative times negative. That will be negative. Then I have a 0 in the denominator. So that's a vertical asymptote. Negative, negative, positive, that becomes positive. I have another 0 in the denominator, so that is going to be vertical asymptote. Negative, positive, negative, that is going to be negative. Then I have a 0 in the numerator, and then finally positive. Okay, now to answer the question at hand, I care about only this part of the picture that I just did. As x approaches 3 from the below, as x approaches 3 from below, it is going to positive infinity because it's a little bit positive. It is positive to the left, immediate left of 3. So that's the infinity that I see here. To the immediate right of 3, it is blowing up, but blowing up negative. And so if x is to the right of 3, it is blowing up, but blowing up in a negative sense. And so once again, I reproduce the same things that I saw here, but based on this little cartoon that I've drawn, as opposed to explicitly plugging in the numbers and caring about what the 0 is positive or negative here. Now, the logic that I see here in green and in black is the exact same logic that I have down here in red, just more schematic as opposed to just plugging in numbers.